Hey everyone, welcome back to Chapter 4, Section 3. In this video we're going to go over solving quadratic equations by completing the square, and in all these examples the a coefficient is going to be equal to 1. So what's similar to the previous video is that all our equations are going to start off in standard form, except with them saying f of x equals, I've replaced the f of x with the 0. So if you ever see a problem like that in the future, you're just trying to solve a quadratic equation and it says f of x equals, just take the f of x off and put a 0 there. Make it say 0 equals or equals 0. And so the reason why completing the square is such a useful method is that you can use it to solve non-factorable quadratic equations. So what I mean by that is, if you look at these examples, there are no factors of 7 that add up to negative 10. The only factors of 7 are 7 and 1. So whether you make one positive and one negative, or they're both positive or they're both negative, they're never going to add up to equal negative 10. Same thing in this example here. There are no factors of 16 that add up to 4. The factors of 16 are 4 and 4, 8 and 2, and 16 and 1. None of those sums add up to 4. So what you'll want to do on problems like this is use the completing the square method. So remember, every time you start off a problem by completing the square, you're going to always move that c term over to the other side, and then you will add a b over 2 squared value to each side and proceed from there. So on this first example, the first thing I'm going to do is minus 7 over to the other side. And so I'm going to write x squared minus 10x. I'll leave a little bit of space. And then I'll write equals 0 minus 7 is negative 7. And now I'm going to add in that b over 2 squared value. So my b term was negative 10 because that's the number by the x. And then negative 10 over 2 squared goes on both sides. Remember, what you do to one side, you have to do to the other. And negative 10 divided by 2 is negative 5, and negative 5 squared is positive 25. So I'm effectively adding in a positive 25 to both sides. So here's what it looks like when I bring down the other terms. What you'll want to do on the left side is factor it, and then the right hand side you can just add these two numbers together. So that part's pretty easy, so I'll do that first. Negative 7 plus 25 is going to be positive 18. And then the left hand side, you can factor this by using the same methods I told you about in the previous video. So if you'll recall, the reason why why it's called completing the square is because you created a perfect square trinomial here. And so when you factor it, it's always going to say x plus a number squared or x minus a number squared. So I'm just going to set this up as x something squared. Alright? And the quickest way to really figure out what that number is going to be is to just look at the number, your b over 2 number, because that number, coincidentally enough, is always going to be the number that's inside the parentheses. So negative 10 over 2 is negative 5. So I'm going to say negative 5, x minus 5 squared. Alright? You want to use this number before you square it, not after you square it. Okay? The other way I can explain it to you is this is a perfect square trinomial. So if you take the square root of the last number, the square root of 25 is plus or minus 5. Whether or not you say x plus 5 squared or x minus 5 squared depends on this middle sign here. This middle sign was negative, so I can factor it by saying x minus 5 squared. And the last way I can explain it is the factors of 25 that add up to negative 10 are negative 5 and negative 5. So since it's the same number twice, you can say x minus 5 squared equals 18. So whatever way makes the most sense to you is the way you should continue to think about it. Now, in the previous video, when I was converting to vertex form, I would just add or subtract this number back over to the other side. But since we're solving, what you want to do now is take the square root of both sides. So when you take the square root of something that's being squared, it's just going to drop the parentheses and drop the power of 2, so it's just going to leave behind the x minus 5. And then the square root of 18 is not a perfect square. So what we're going to have to do is we're going to have to simplify it. You got to think, what two factors of 18 have a perfect square? So really it's just going to be one factor of 18 that has a perfect square. All right. So what I'm getting at is the factors of 18 are 18 and 1, 6 and 3, and 9 and 2. I'm going to use 9 and 2 because the square root of 9 is a perfect square. It's 3. So the square root of 9 is plus or minus 3. Remember, you always have to do plus or minus. And then 9 times 2 is 18. So you can rewrite the square root of 18 as the square root of 9 times the square root of 2. And since the square root of 9 is 3, or plus or minus 3, you say the square root of 18 equals plus or minus 3 square root 2. And then after you get that, you can just add 5 over to the other side. And then what you'll want to do is you'll want to put that in front. So you'll say x equals, so it was positive 5, so I'll just say it, or I was plusing 5, so that's the same thing as a positive 5. And then I'll put plus or minus 3 square root 2. And oftentimes this is good enough for your final answer, but your teacher may ask you to give him or her the rounded answer. So to get that rounded answer, you're going to take the 5 plus or minus 3 square root 2, and then you'll type that into your graphing calculator or scientific calculator or whatever. So just write 5 plus 3 square root 2, and then do it again, 5 minus 3 square root 2. And then you'll have to round your answer to whatever decimal place. So I rounded my answer to the nearest thousandths place. So all this, the 9.2426, that 6 rounds that 2 up to a 3. And this one was 0.757. That 3 does not round up, that's 7. So yeah, that's how I got my two answers. Now, the other way you could get your answers is by graphing it. So if the answer has real solutions like this one does, meaning it doesn't have any imaginary solutions, then you can just skip all this and just type in the original equation into a graphing calculator and then tap on the x-intercepts, and you'll get what we just got right there by using the calculator. So earlier I said if it has real solutions, then you can just use the graphing calculator to get the solutions. Well, if it never touches the x-axis, then it won't have any solutions. So this is the graph of x squared plus 4x plus 16 equals 0. Well, whenever I graph it, by the way, I don't type in the equals 0. Because if you type in the equals 0, you won't see the full parabola or anything like that. So I recommend graphing it without the equals 0 part, and then just, tapping or clicking on the x-intercepts yourself. Only if there's no x-intercept, then that tells you you're going to have imaginary solutions. If you have imaginary solutions, you're going to have to solve it by hand. So I recommend using the completing the square method, because to me that's my favorite method to solve by hand. So just like in the other problems, to start off by completing the square, you're going to take that c term and add or subtract it to the other side. So 0 minus 16 gives me a negative 16. And then what you're going to do is you're going to add in the b over 2 squared value to both sides. So my b term, the number by the x, is a 4. So I'm going to add in a 4 over 2 squared to both sides. 4 divided by 2 is 2, and 2 squared is 4. So really I'm just adding in a 4 to both sides. So what we need to do now is just combine the two numbers that are on the right hand side. Negative 16 plus 4 is negative 12. And the left hand side is going to factor. So remember, the quickest way of factoring it is it's going to be x plus a number squared or x minus a number squared. And the quickest way of factoring it is to just look at this number before you square it. 4 divided by 2 is 2. And since it was a positive 2, you'll put a plus 2 there. Also, you could think of the factors of 4 that add up to 4 are 2 and 2. 2 plus 2 is 4, 2 times 2 is 4. So you're going to write x plus 2 times x plus 2, which is the same thing as x plus 2 squared. Okay? So anyway, once you get to this step, you have to square root both sides. So you keep the negative 12 there, and you're going to square root both sides. And when you square root a negative number, you get an imaginary solution. So the left-hand side is just going to turn into x plus 2 because the square root will cancel out the power of 2, and then you don't need the parentheses anymore after that. And then the square root of negative 12, well, the square root of 12 is not a perfect square. So you got to think, what are my factors of 12? And are any of those factors perfect squares? So my factors of 12 are 12 and 1 and 6 times 2 and 4 times 3. 12 and 1, toss them out. Neither one of those is perfect square. Well, 1 is technically, but that doesn't help. And then 6 and 2, the square root of 6 is not a perfect square. The square root of 2 is not a perfect square. So 4 and 3, the square root of 4 is a perfect square. That's 2. 2 times 2 is 4, right? So I'm going to put the negative with the 4, like I did right there, because I can take the square root of negative 4. I can say that's plus or minus 2i. And then the square root of 3 would just stay behind as the square root of 3. And then for my final step here, I just need to minus the 2 over to the other side. Just remember, after you add or subtract that number to the other side, put it in front of the plus or minus number. So since this number was imaginary, you don't need to give me a rounded answer for that. So your teacher should let you write this for your final answer. If you're one of my students, I would tell you yes, write it like this for your final answer. Okay, looking at my last problem here, if you were to graph it first, you'd see that this parabola does not touch the x-axis, therefore it's not going to have any real solutions, it's going to have imaginary solutions, so that means I'm going to have to solve this by hand. So to complete the square, I'm going to add or subtract the original c term over to the other side, and then I'm going to look at that b term. That b term is 8, so I'm going to write 8 over 2 squared on both sides. 8 divided by 2 is 4, and 4 squared is 16, so I'm adding a 16 to both sides. Bring the rest of the problem down, and now it's time to simplify. Negative 20 plus 16 will equal negative 4, and then x squared plus 8x plus 16 will factor to get x plus 4 squared. How did I know that so quickly? 8 divided by 2 is a positive 4, so it's going to say x plus 4 squared. Or, one of the other ways I explained it earlier is you could take the square root of this last number, that's going to be 4. The square root of 16 is 4, plus or minus 4, I should say. And so, is it going to be x plus 4 squared or x minus 4 squared? Look at the middle sign for that answer. So since it's a plus 8x, I'm going to say x plus 4 squared. From here, you'll want to square root both sides to get rid of the power of 2. So that's just going to leave behind your x plus 4. And the square root of negative 4 is a perfect square. The square root of 4 is 2, or plus or minus 2, I should say. So you're just going to say this is plus or minus 2i. A lot of times kids get in the habit of simplifying their square roots when they don't need to. And what I mean by that is, when you take the square root of something, you are simplifying it. But what I mean by that is, they think you have to, every time you take the square root of a number, they think you have to do this every time, like break it down into the factors. And so then kids usually end up writing some weird answer like the square root of 4 is 2 square root 2. Remember, you can always type this stuff into a calculator to check. Type in the square root of 4, like just drop the negative, and then don't forget to put an I by your answer. Type in the square root of 4, your calculator is going to tell you 2. If you type in 2 square root 2, it's going to give you a completely different value. So basically, the moral of this story is learn your perfect squares so you don't make this mistake. So the square root of negative 4 is going to be plus or minus 2i, because the square root of 4 is plus or minus 2. Since it's negative, throw an I there. Then you just got to minus the 4 over to the other side. And then just don't forget to write that number out in front. So this is actually your final answer, negative 4 plus or minus 2i. So that's going to draw these notes to a close. Thank you for watching. Hope you learned something, and goodbye.